Today we are going to learn about electric dipole. I sent you the notes in WhatsApp group. I hope you all have copied them. So in this video I am going to teach you electric dipole in details. What is an electric dipole? An electric dipole is a pair of equal and opposite point charges placed at a short distance apart. Something like this. This is one point charge, this is another point charge. We take this point charge to be minus q and this charge to be plus q. See, both the charges are equal in magnitude, that is q, but opposite in sign. One is minus and the other is plus. Now always remember that the length of an electric dipole is always taken as 2L. 2L. Now why? That we will know later while performing the numericals. We will see that it is easier to do the calculations if we take the length of the dipole to be 2L instead of L. Now we will know electric dipole moment. What is electric dipole moment represented by P vector? What is this electric dipole moment? Electric dipole moment is the product of charge on the dipole and length of the dipole. Charge is q and length I told you 2L. Hence we get the magnitude of electric dipole moment as 2QL. Now this is the magnitude of electric dipole moment. But we know that electric dipole moment is a vector quantity, as we can see here. And a vector quantity comprises of both magnitude as well as direction. So what is the direction of electric dipole moment? The direction is from the negative charge towards the positive charge along the axis of the dipole. I repeat, from the negative charge towards the positive charge along the axis of the dipole. That's the direction of electric dipole moment. Now we are going to learn about the intensity of electric field at a point on the axis of the dipole, which is also known as end-on position intensity. Okay, let me draw the diagram first. Now I told you that the length of the dipole is taken as 2L. So suppose this is the midpoint of the dipole, then this has to be L and this has to be L. That gives us 2L as the length of the dipole. We take O as the midpoint on the axis of the dipole. Now we want to find the electric field at a point on the axis of the dipole. That is, suppose this is the axis of the dipole. We want to find electric field at this point, P, which is at a distance R from the center of the dipole. Now there will be electric field due to two charges. One is plus q and other is due to the minus q. Now I told you earlier that the direction of electric field for a positive charge is away from the charge. So this is positive charge q. So the direction of electric field due to this charge will be away from the charge. So let us take this to be E1. And the direction of electric field due to the negative charge minus q will be towards the charge, towards the negative charge. So let us name this electric field to be E2. Now we know that the magnitude of electric field is given by 1 by 4 pi epsilon naught into into the charge for which we are finding the electric field by square of the distance. Square of the distance, what distance? Distance from the charge to the point at which the electric field is required. So E1, we are finding E1. E1 is for the charge plus Q. E1 is the electric field due to the charge plus Q. So Q by distance square. Now distance from the charge Q to the point P. Now what will be the distance? Look, this total distance is R. This total distance is R, and this much distance, that is distance from O to B, this distance is L. So distance from B to P, distance from B to, okay, I am writing it. See, carefully observe, the distance from O to P is R, and distance from O to B is L. So distance from B to P has to be R minus L. So the distance is R minus L, and distance square will be R minus L whole square. So this is our E1. Now similarly E2 will be 1 by 4 pi epsilon naught into charge by distance square. 1 by 4 pi epsilon naught into magnitude of the charge by distance square. Now distance due to which charge? This E2, we are finding E2, and E2 is due to the charge minus Q. So distance from minus Q to P, this is R, this is L. So the total distance should be R plus L. So the distance square will be R plus L whole square. Now these two are two vector quantities, E1 and E2, and they are oriented in the opposite direction. We know that if the direction is opposite, then the resultant vector quantity or the resultant electric field has to be the difference of the two electric fields. So let us take the resultant electric field to be E parallel. This end on position intensity is symbolized by E parallel. Now E parallel should be equals to E1 minus E2 because they are in the opposite direction. So E1 is, okay, the video got paused. I didn't notice, so I have written it already, so just go through this. E1 minus E2. Now E1 we have 1 by 4 pi epsilon naught Q by R minus L whole square, and E2 we have 1 by 4 pi epsilon naught Q by R plus L whole square. We take Q by 4 pi epsilon naught common from both the terms. We get 1 by Q by 4 pi epsilon naught into 1 by R minus L whole square minus 1 by R plus L whole square. Now E parallel equals to, we have got here this 1 Q by 4 pi epsilon naught into 1 by R minus L whole square minus 1 by R plus L whole square. So I have written that over here. Now we take the LCM, we get R minus L whole square into R plus L whole square in the denominator, and the numerator we have R plus L whole square minus R minus L whole square in the numerator. Now we know the formula that R plus L whole square minus R minus L whole square will be 4RL, and the denominator can be expressed as R minus L into R plus L whole square. Now this R minus L into R plus L will be R square plus L square whole square in the next step. So we have Q by 4 pi epsilon naught into 4RL into R square minus L square whole square. Now we can express this as 1 by 4 pi epsilon naught 4QRL by R square minus L square whole square, which again can be expressed as 1 by 4 pi epsilon naught 2 into 2r into 2ql by r square minus l square whole square. Now 2ql is the dipole moment P. See, over here we have written 2ql is P, dipole moment. So over here in place of 2ql we can substitute the dipole moment P. So 1 by 4 pi epsilon naught 2r into P by r square minus l square whole square. Hence we have the final formula of E parallel as 1 by 4 pi epsilon naught 2pr by r square minus l square whole square. Now we have a special case over here that if r is much greater as compared to l, that is the distance the distance from the center of the dipole to the point at which electric field is required is much greater compared to the half of the length of the dipole, that is L. If r greater than L, then we can ignore the L. So if we ignore the L, we get the formula E parallel equals to 1 by 4 pi epsilon naught into 2pr by, we are ignoring the L, so we have only r square whole square. There is r to the power 4 which gets cancelled to give r cube. So we have the E parallel formula as 1 by 4 pi epsilon naught into 2p by r cube. This is the formula for E parallel if r is much greater as compared to L. Next we are going to learn few important properties of electric lines of force. Properties of electric lines of force. First property is that, suppose this is an electric line of force, the tangent at any point, suppose this is one point, and the tangent at any point on the electric field gives us the direction of the electric field at that point. So suppose here is a positive charge and here is a negative charge. So for the direction of electric field will be like this, from the positive charge towards the negative charge. Now this direction varies point to point. At this point the direction is this. At this point, so we have to draw the tangent at this point, which gives us the direction of electric field in this direction. So this is E1 vector, this is E2 vector, like this. The tangent at different points gives us direction of electric field at that point. Number 2, second property is two electric lines of forces cannot intersect each other. Why? Because if they did, then at one point we will get two tangents at a single point. We will be having two different directions of electric field, which is not possible. So two electric lines of force cannot intersect each other. This is not possible. Third property is that electric lines of force do not pass through a conductor. Electric lines of force do not pass through a conductor. And the last important property is that the electric lines of force are continuous and does not have any breaks in between. Means they are continuous. Electric lines of force do not have breaks like this. They do not have breaks in between. They are continuous lines. Okay, so that was all for today. I hope you have understood what I taught. If you have any doubt, you can give me a call or you can write the doubt in the WhatsApp group. I will respond. Thank you.